All right, so note 4, covalent bonding. Yesterday, the notes were about ionic bonding, and as a review, ionic bonding was a transfer of electrons. So as a review, ionic bonding was a transfer of electrons, okay? Now, covalent bonding is different than ionic bonding in that we are not transferring electrons, we are sharing electrons, and there's an actual definition for that in a little bit, but we'll move forward first of all. So this next portion is another simulation, so I'm going to go to the simulation and we're going to talk about it, which is good, clean family fun. So I don't need you to write anything down at this point in time. I need you to put your pencils down and pay attention up here, up on the front, because this one is pretty good. Okay. You make me stutter. Now, covalent bonding is typically explained as a bond that forms when two atoms are sharing electrons. So in this particular tutorial, we are going to explain what this means and show you how the process of sharing electrons holds things together. So up on the front here, we have two hydrogen atoms, and those two hydrogen atoms have black dots around them, and those black dots around them are representative of electrons. Okay, so what I'm telling you right now is that a hydrogen atom in its neutral state will have one valence electron. So it's telling me to try to move them. So I'm going to move these atoms closer to one another and see what happens. Oh, as we get closer, so we'll go back over here, moving them closer. They attract to one another, and they appear to be like being okay with each other. But if I push them closer, they would start to repel. So there is a point where there is no attraction. Then there is a point where there is attraction. And if I push them closer together, there is repulsion. Okay? Now, so here's the thing. Take a second, look at the electrons, and note that when I get the electrons close together, or when I get the atoms close together, what happens to the electrons now versus how they were behaving before? So the electrons before were flying how? Everywhere. Now where are the electrons flying? They're in between the two atoms, right? And that's an important thing to understand. So if I push them closer together, again, they just kind of keep repelling each other. Now, there's another way to look at this. Look at the electron. Look at the atom with the electron on the left. That one has a line indicating that it's trying to just show you how that atom or that electron is being attracted to the nucleus of that particular atom. Okay. Now, if I move this guy over here, and I can't move him. So we're just showing that for a second. But now take a look at what happens as they get closer to one another. As they get closer to one another, do you see how that line for that original atom appears to get longer? What's happening here is the nucleus of the atom on the right is attracting the electron from the atom on the left, and they are getting closer and closer to one another. So there is an attraction from the electron to the nucleus of both of these atoms. Okay, and as they continue to get closer, hopefully you can see is that now both of the electrons are spending a lot of their time in between the two nucleus of the atoms, and it appears as they are really spending a lot of their time with one of them. Okay, but what really happens here is that these electrons are being attracted by each atom at the same time, and as a result of that, they're spending more time in the middle than all over the place. Now, this explanation here is something I've never actually used before, and I like it. We're calling this a covalent bond. And the definition of a covalent bond that you've probably heard before, and I'm going to tell you right now, is that atoms are sharing electrons. The problem is they're not actually sharing electrons, they're fighting over them. And I like that because that's really what's occurring here. So there is an attraction from one atom to another atom's electron, and then there is a repulsion from one atom to his own electron. So the issue is that these two atoms, when they're participating in a covalent bond, are sharing time with the electron, if that makes sense. Now, a couple of things we should talk about. Covalent or ionic bonds that we talked about yesterday occurred between metals and nonmetals, whereas covalent bonds tend to occur between nonmetal and nonmetals only. So only the atoms that appear on the right side of the periodic table. So a covalent bond tends to form between two nonmetal atoms, and each atom will attract an electron, which pulls the atom together. Okay? One thing that you should be making note of here, hydrogen is not a metal, it's a gas at room temperature, and as a result of it, it behaves like a nonmetal. So in this case, hydrogen falls in the nonmetal category. Now, this is going to create a graph of something we call potential energy. At some point in your life, you may have heard about potential versus kinetic energy. Kinetic energy is the energy of movement. Potential energy is stored energy, right? Okay, so when I move these two atoms closer together, the graph is going to create a curve that is going to look at potential energy. So over here, as they get closer together, do you see how the curve is starting to dip down a little bit? So what this is showing you is that as atoms get closer together, they start to lose potential energy, which is a good thing. We'll talk about why in a second. And so as we get closer and closer together, that level of potential energy decreases to a point where we would like to refer to that, I guess, as the sweet spot, because now look at how those electrons are very, very close to them in between the two atoms. They're being shared or fought over equally. But if we squish them closer together, they want to repel. And when they want to repel, the potential energy goes through the roof. Okay? So what we're really looking for here is this very, very potential sweet spot where they are no longer attracted nor repelling each other. And when they get to that particular point in time, we call that a covalent bond. Lost my word for a second there. Okay. So the deal is that when atoms are arranged so that potential energy is a minimum, there's a stable balance between the attractions and the repulsion of the two atoms in question. The distance between these two atoms is called the length of the bond. This is also referred to as where the lowest potential energy occurs between two atoms, and that is an incredibly more stable environment. So the thing is that all atoms want to bond to get to 8 valence electrons, but they also want to bond to lower their potential energy to become more stable. You are probably at your most stable when you are sleeping, because you're resting. You should have nap time. So lower potential energy equals more stable for each atom. Now, we can draw pictures of molecules, and when you draw them as molecules, we often use a solid line, a single line, to indicate that a pair of electrons is being shared. So the H-H is the same thing as two circles with two dots. Okay? Sometimes atoms will form multiple bonds, in which case they will share two pairs of electrons, and we would call this a double bond. And sometimes they will form they will share 3 pairs of electrons, and we will call this a triple bond. So the 3 types of covalent bonds that can occur are the single bond, the double bond, and the triple bond. The triple bonds are the strongest. They're the most difficult to break. The single bonds are the weakest. They're easier to break. So naming these guys is going to become important at some point in the future. So looking at this, NO2 is something we call nitrogen dioxide. N2O3 is dinitrogen trioxide. CCl4 is carbon tetrachloride. And Cl2O is dichlorine monoxide. And S2Cl2 is disulfur chloride. The reason why I bring this up is because if we're looking at a pattern here, one of the patterns is that all of the names for these compounds end with IDE. There's also prefixes added to the elements to indicate how many atoms of each of those are present. So for example, Di tells you that there are 2 oxygen atoms, or tri tells you there's 3 oxygen atoms, or tetra tells you there are tetraskames occurring, or 4 chlorine atoms. Mono means 1. Now, do you need to know this? Not really ish. I'm just showing you so you have an idea of what's going on if you ever see these words before. So like so in the first case, we'll be looking for something called dinitrogen monoxide. For NO2 would be nitrogen dioxide. For N2O3 is dinitrogen trioxide. And NO would be nitrogen monoxide. Okay? Mono means 1. Mono, right? Disulfur chloride would be S2Cl. 2. SO2 would be sulfur dioxide. S2O3 would be disulfur trioxide. And S2O would be disulfur monoxide. That's a wonderful thing. So we've learned some stuff. So now we need to go back to our notes and move forward and talk a little bit more. So how a covalent bond forms. You saw this in the tutorial. You might want to draw this now. We're back to reality. And so you might want to draw this. So you might want to draw this because this is how a covalent bond forms. This is the part where you put the pencil back on the paper and you draw some stuff. So the first thing, right. So in the first box, we have 2 atoms, right? They're both hydrogen atoms, and they're pretty far apart from one another. And as they're pretty far apart from one another, there's no attraction. There's no attraction. As they get closer, though, when they get to the very, very, very perfect spot, the attraction and repulsion cancel out so they can bond. And that's how a bond forms. So when they're at that spot, you have a bond forming. Question about that?
Repulsion meaning go the opposite.
Yes. Attraction means bring together. Repulsion means to separate or push apart. Kind of like when your grandma wants to give you a hug or a kiss. Or your aunt wants to kiss you on the lips. That's weird, right?
Yeah.
That happens though, right?
No. That's like
It is, but
crunchy stuff.
it is crunchy. It's like crunchy hippie stuff, but it happens.
Country, like hick stuff.
Oh no, like don't you have that one aunt that's very handsy?
No.
Like not in a bad way, but like she's like hugging and
In our like culture, we
Cheek.
like kiss on cheek, but like some of them are like black kisses, and that's disgusting.
all right.
That's why I don't that's why I don't kiss my grandma on my dad's side. I don't even like him.
Moving on.
Like,
It's supposed to be like your cheeks hitting, not an actual thing, but we don't know.
Now, here is the definition of a covalent bond that you are going to be responsible for understanding. The covalent bond is the attraction between the 2 atoms that are held together by their mutual attraction for shared atoms. So shared electrons. You should probably fill this in up here, right?
I just need to go back.
Why?
Because
You can watch the video.
Yes,
don't want to watch the video.
I do.
Come on.
Dude.
So, covalent bond is the attraction between 2 atoms that are held together by their mutual attraction for their shared electrons. I'll go back later. Okay?
Once I draw the H's.
No, because you should have already drawn them above.
That's what I do.
Gotcha. Can I go on now?
Yeah.
No.
Yeah, go ahead. Dude.
Moving on. Now, here are the rules. Here are the rules. Okay? You should draw this in the 3 boxes below. Lillian. Now, first of all, draw the Lewis dot structure for the individual atoms. That's box 1. Box 2, draw the chemical symbols next to each other so that shared electrons are between the 2 atoms. Then circle these shared electrons. I know. replace the shared electron pairs with a line from one chemical symbol to the other, and then that is a covalent bond. It's easy to do.
Another school shooting.
Hey,
Are we good here?
no.
Can I move on? You were back there chair dancing instead of drawing. That's not my problem.
Do we care about school or do we care about school shootings?
At this point, I care about this content. Are we ready to move on?
You don't care about her life.
Next. Sometimes atom will share more than 2 electrons. These covalent bonds are known as double bonds and triple bonds. So in this case here, I have 2 oxygen atoms. Each oxygen atom has 6 valence electrons to start with. As a result of it having 6 valence electrons to start with, they both want to get to 8. So I line up the unshared electrons and share them and create a double bond. Do you see how that works? And then I'm going to do an example problem with you.
Yes, you can move on.
No, you can.
No, how did you write that so fast?
Bro,
She's like Superwoman over here.
I've been doing it while he
Superwoman
picked it
doesn't have
up.
the strength to be boss.
Not sure.
Can I move on now?
No.
No.
Those other people are done. You mean they're done.
So
Doesn't work.
It's only dots, Mr. Selfie.
But I get to be in the right. I mean,
all right.
You're not moving.
Do not.
Then you not transfer the day or I don't.
We have one more slide to go. We can get there.
Okay, go ahead.
No, did not go on.
You got it. Never mind. You probably don't.
Moving on.
Yeah.
No,
Oh my gosh. Watch the video, Josh.
why did only the
they're
two get circled? 2 of each. Just one and one.
Because in order because in this case here, that would give that oxygen 8 electrons, and then this would give this oxygen 8 electrons because they're
So
sharing
whatever it is
pairs.
to get to 8 is what you share.
Yeah. Now, last thing. So we have to draw the original Lewis structure for carbon and oxygen. Now, I know that carbon has 4 valence electrons, and I know that oxygen has 6 valence electrons, and there happens to be 2 of them. So one of the rules that you might want to understand is that when there's one atom compared to multiple atoms, that one usually goes in the middle, and then we're going to put the oxygens on the sides, and then we're going to fill in the valence electrons. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, and the carbon has 1, 2, 3, 4. Now, what I'm going to do is I'm going to look where carbon and oxygen could share electrons, and they share electrons when they don't have pairs already. So I'm going to pair up these 2 guys, draw them a circle, and these 2 guys. Why are you packing up? We're not done yet. And these 2 guys, and these 2 guys. Look what I did there. So I did. So I have carbon and I have oxygen, and each of those circles represents a bond. And when all is said and done, I still have to put the remaining electrons left there. That compound is actually carbon dioxide, which is the hot breath coming out of your mouths half the time. Now, right. Now, your homework, ladies and gentlemen, is to do worksheet number 4, which is the covalent bonding worksheet.
There's no clues. Five, all fives.
Have a good day.
We got homework?
Yes.
Ready? Five.
Bring that here.
Shut up, Mark.
Man, you like. I just repeat. You're Mr. Feet, dude.
Have a good day, ladies and gentlemen.